So die casting is obviously a liquid metal casting process. So what does that mean? That means we're using liquid metal as the feed material. We're going to go through a solidification process from liquid to solid, and the goal is to produce either net shape, i.e. we cast it and basically ship it, or near net shape, where we cast it and have to do a minimal amount of finishing operations to the component before we ship it to the customer. Obviously, the value is added during the casting process. We want to get as close to the final shape as possible. That's the whole point of casting processes, and therefore we want to minimize any expensive finishing operations that we have to do to the part. And we're going to produce these, as I said, from aluminum, magnesium, and zinc alloys. And with die casting, we're going to inject the liquid metal. And so we're not pouring, as in many casting processes. We're going to use a hydraulically activated ram, and we're going to inject the liquid metal into reusable steel dies. So we're going to have steel dies, and we're going to reuse the same die time after time after time. We're going to inject it at very high speeds. And so normally the speed at which the metal is entering the cavity is somewhere between 100 to 200 feet per second. To put that in perspective, that's about half a football field in a second. And we're going to purposely break the liquid metal up into a spray as it enters the cavity. And so when you go to die casting school and when you kind of learn how to produce a die and how to inject the metal, we look at purposely breaking the liquid metal up into a spray that allows us to fill the cavity really, really quickly. It allows us to get very, very good surface quality on our castings and to fill the extremities of the cavity. Once the cavity is filled, we're going to continue to press on the liquid metal as it is solidifying, as it's cooling. We want to try and push more liquid metal into the cavity, and for two reasons: to shrink down any entrapped gas and to feed solidification shrinkage. And we'll talk about these things in a bit more detail. I think it was part 3 when we're going to talk about defects and minimalization of defects. How much pressure do we apply? We're applying really high pressures, probably 4,000 psi on the low end, up to 20,000 psi. I think 10,000 would be more typical, but with some of the high integrity processes, maybe as high as 20,000 psi. So we're really pushing hard on the metal. So the real 3 critical parts of this is the reusable steel die, high speed injection, and the high pressure once the castings are solidified. So those are the 3 real traits of the high pressure die casting process.
To purchase access to this course, visit the NADCA Marketplace at www.diecasting.org/store. Purchasing a course through the online education system grants you 1 year of access to the recording, presentation, support material, and test when applicable. NADCA video news and information is brought to you by the following sponsors.